This will actually just be a library talk. I hope that's okay with everyone. So the problem is you often need to edit something serious in a web component. Interfaces of web pages and web applications are getting more and more complicated, and the common things are you want templates or you want a query or something to be written by users. People are even building whole integrated development environments inside of the browser. And HTML has a text editor built in. It's the text area element. But it's about on par with Notepad if you're talking about serious code editing. And to make things worse, it has this very, very minimalistic programming interface. You can get its value out. You can give it a new value. You can even, if you are willing to put up with some pain on Internet Explorer, get the selection, and that's pretty much where it stops. So for typical things where you just want to go in and adjust some code, query what the user is actually doing, it doesn't scale. Also because if you have a few thousand lines of code and you want to get and set the value of a text area, that's still on modern browsers seriously slow. There used to be in the mid-2000s a project called Edit Area, which built a relatively workable code editor on top of a text area, but it's since been superseded by better things. These are the three main projects currently in existence. They're all open source, developed in the open with active communities, open repositories and bug trackers. Actually, I'm not sure about Orion's bug tracker, but ACE and CodeMirror are on GitHub. ACE stands for the ajax.org code editor, where ajax.org is the old name of the company that now does the Cloud9 integrated development environment, which is a really, really slick online integrated development environment. It's focused on JavaScript mostly, doing both client and server-side stuff with Node. It hooks into a debugger that it runs on some Amazon server for you. You have direct access to Git commands, and it's very well done. So they built their own editor for this around end of 2010, I think it was first released. CodeMirror is my baby, it's my project. The few of you who've seen my name before probably know it from my book called Eloquent JavaScript, which I published in 2007 online. It's a book about JavaScript which has an integrated environment for trying out code snippets, editing them, running them. And I needed a good code editor for that, and none was forthcoming, so that's when I implemented the first version of CodeMirror. Around 2011, when ACE had come along, ACE kind of outgunned CodeMirror on most of the coolness factor and the speed and the features. So I rewrote it from scratch using some of the techniques that I stole from ACE. And now it's pretty much on par with that. Then the third one is a bit the odd one out. This is called Orion. It's developed by the Eclipse Foundation for their, they're also working on an online code editor environment, which is as a whole called Orion, but the editor component can be run separately from the rest, from the backend. They're not getting quite as much press at the moment, but they're hard at work, and I think they're building up great stuff. It uses a different implementation technique than the other two. I'll come back to that at the end of the talk, but most of the things I'll be illustrating in my talk apply to CodeMirror directly, and ACE because it has a very similar implementation. Orion is different. I'll briefly come back to it later. So why would I even re-implement CodeMirror to use the same techniques that ACE has? It's mostly a matter of pride. I had this project which was dominant for a while in the code editor space, and then these upstarts came along and they wrote something that was better. And of course, I couldn't let that happen. But that's not the only difference. Ace is a very opinionated, all bells and whistles included kind of editor. You just drop it into your page and you have all the features running and going. And CodeMirror, on the other hand, is minimal, super configurable kind of thing where if you really want something specific, it can do it. It can adjust to basically almost everything you'd want to do. It's also 3 times smaller than Ace, and I'm biased, but I feel that it has a more pleasant interface. But actually, I should not compare them because it's like, I don't know, asking the Pope about independent comparing of the various world religions. Let's see what we can actually do. These slides are just running in HTML. They, yeah, what you see here is a real text area. So it's a little narrow, but here if I press enter, it indents all the way back to the side because it doesn't know anything about code editing. Let's replace it with CodeMirror. You don't see the difference because I styled them to be the same, but this is actually CodeMirror. And I press enter and it knows that we'll probably want to indent to the same depth as the line before it. But that's all it knows, and this is of course configurable. You can make it do anything you want when enter is pressed. Things would probably be better if we told it the language that we're using. This is JavaScript. This is actually the code that powers these slides. It's pretty horrible code. You shouldn't actually read it. But it's colored now. It knows what a string is, what a command is. It recognizes keywords. And it also knows about blocks. So if I press enter here, it'll see, oh, you opened a block, so I should probably indent that. If I press enter in the middle of a list that's parenthesed, it'll also nicely align it. It's gotten slightly more clever because there's a program written called the JavaScript mode, and there's modes for lots of languages. I'll come back to that later, which are basically like little parsers that can tell the editor about highlighting and give some contextual information that it can use, for example, for indentation. That was not what I wanted to do. The styling can be completely adjusted using style sheets. This is a theme, one of the few themes that were contributed that were not programmer art style of super simple, minimal stuff, but done by someone who's actually somewhat proficient in graphics. We can just tell it to add a line number bar to the side to make it look somewhat more professional. All these set option calls, you don't actually have to do that. You can usually just initialize it with all the options you want. But here I'm like going step by step to see where it starts and what you can add. Let's say we want to add code folding. First we make some space for an extra gutter. Here we tell it that we want 2 gutters, one for the line numbers and one for our fold markers. The fold marker string is a CSS class that will specify the width of this. Next, we'll register an event handler. If someone clicks on the gutter, it will call this function, which here is called maybe fold code. This is not part of the core. The core is very minimal, but the distribution includes a bunch of add-ons, which, for example, let you fold code. Other things that are extensions or add-ons are search replace. If I do search, it'll just search through my documents. If I do replace, I can replace all the instances of window and save like 16 bytes on my JavaScript file with the word top. Yeah, another thing I wanted to show was, here I rigged something to show a simple auto-completion if you press Ctrl space. It also does some clever things where it inspects the current environment, and well, these don't look right. I probably screwed up some style sheet. It looks in your current environment to give you hints. You can actually, it's pretty primitive. You could write a much more clever autocompleter, and because it's pluggable, you can basically go crazy with cleverness. Here I added another external program which, whenever the content of the editor changes, it'll call this runLinter function, which is based on JS hint, which is a linter, a static linter for JavaScript. And whenever it finds a problem, it'll inline show it as a little exclamation mark widget. If we compare with Ace, it looks extremely similar, like eerily similar. It's just the theme is different. You can probably style them to look exactly the same if you really wanted to. But it has all this. This is like I just dropped it in with 3 lines of code, and it already has the folding running, and I think it also does linting. Yeah, here we are. It says missing semicolon. So it's a more opinionated, everything included kind of library. I didn't actually set up an instance of Orion here, but it looks very similar because code editors have converged to a kind of look. I'm actually coming from an Emacs background, so I had to make some things non-weird in the process of getting feedback from users who were not quite familiar with the Emacs-based features that I was building. But yeah, I've converged on a standard component which can be configured. You can even add key binding maps where you just redefine every key to the point that the browser allows. So unfortunately, the browser captures some things like Ctrl-W, Ctrl-P. At least Chrome does capture them unconditionally. You can't overwrite them. So full Emacs bindings are only possible in Firefox, which lets you redefine every single key on the planet. So as I said, browsers don't really do code editing. Yet we just saw 2 code editors. Some magic was required. The rest of my talk will be spent looking under the hood of these editors and seeing how they actually do their thing. First of all, you saw a cursor there. It moved when I typed, it's blinked, it's behaved exactly like a cursor. It's not actually a cursor. At least the browser and the operating system do not think this is a cursor. It's actually just a div element that I absolutely positioned over the text and blink with a set timeout to make it look cursor-like. But of course, this is possible. You can draw quite a lot. CodeMirror doesn't use any kind of canvas. It's all DOM nodes. DOM nodes are faster in practice than canvas because the browser knows more about them and can display them more cleverly. But you can imagine how this works. You just keep your own model of the document, keep your own selection, draw things in a way that is expected from an editor, listen to key events and respond to them in the appropriate way. If someone presses left, you move your internal cursor position a bit, you update your cursor, and it just looks like you have a real editing component. The thing is, with key events, you could just listen globally, which there's one very cool project called YMax, which is an Emacs clone, which does just that. It just listens to key events on the global window object and fakes everything from there. The problem is that then you're not really being a good citizen anymore. The rest of the page will be unable to get focused because you're grabbing all events from the top level, and you can't type into anything else or do anything else with the keyboard, so that's not a good solution. What we want is actually respect the tabbing regime, the focus regime of the browser, where you can tab through and actually end up in your code editor, and then when you press tab again, if you didn't bind tab to something else in your editor, move to the next field, and so on. So to do that, there's a text area actually being created by the code editor, and then hidden, which acts as our input shim. The thing is, we can't just do display none or visibility hidden on the thing, because then the browser will refuse to focus it. What we're doing instead is wrapping it in an overflow hidden div and making that height 0. You still don't see it, but the browser doesn't realize that it's invisible. So it'll happily focus it for you. And at that point, we know a focus event fires on this thing, so we know we're focused. We register our key event handlers on this actual text area, so we can capture them locally instead of globally. And this works very well. Another advantage is that the input is already in this text area, so when text is typed, it'll appear there. We don't have to mangle key events to get regularly typed text. We can just wait for it to appear in the text area, move it into our own representation of the document. And there are some advanced input things, like there's IME, input method editor, that's used by a lot of East Asian languages to compose characters by multiple keystrokes. The key events there will be almost meaningless. What you want is the actual input that the operating system makes of it. And this actual input will end up in the text area, so this helps us support that. Same for paste. You don't have access to the clipboard from JavaScript, but if the user pastes, his text will end up in the currently focused controls, so we get the text we want. There's for cut and copy, you also want, whenever this happens, the selection in the text area to match the actual selected text in the editor, so that you actually get the stuff on your clipboard that you were hoping for. One solution is just to always put the selection in the text area, but if someone presses Ctrl-A in a huge document, that'll be a lot of data, and as I said, setting the value on a text area is amazingly slow, which is probably understandable because it has to populate this editable control, which is non-trivial, and it doesn't know if only a small thing changed. It has to just rebuild its whole representation. So we want to avoid that. To do that, we can just wait for a cut or a copy event to fire. They fire, like browser events, they fire before the actual cut or copy takes place. So when this happens, we quickly switch in the document, the current selection, into the text area. And everything works. Well, the last hack doesn't work on Opera, which doesn't do cut, copy, and paste events, but there we just put in the whole selection. And if it's too slow, they should use another browser or something. That's not the whole story of making something behave like a convincing editable component. There's also, for example, drag and drop. You want drag and drop to work. There's a good API for that, which is supported by all modern browsers, so that was relatively trivial to hook up. Then there's context menu. If you right-click on your editable component, you expect cut, copy, paste, and select all to be present in the menu. But people are just clicking some random div, which is not an editable component. So we have to trick the browser, and it's actually possible, though weird. This event fires before the menu is opened. So when CodeMirror notices a context menu event, or on Firefox a right-click event, because Firefox's context menu event fires too late, what we do is we make this text area almost transparent so that it doesn't draw attention to itself. We make it small and we shove it under the mouse cursor. It actually works. It's a horrible, horrible hack, but it does the trick. The context menu will actually be associated with the text area at this point, which we can hide immediately afterwards, so you don't really see it unless you're looking for it. And if you paste from there, it'll end up in the text area. Same, we can do the same trick again, where we put the selection in there so that if you copy or cut, you also get what you want. Select all requires another step of hackery, where we add an extra character that's not selected, and then after the context menu opens, we poll for a while whether that character got selected, and if it did, then they probably clicked select all, so we select the whole document. Yeah. It's a shame, and a real API would have been great, but this works, and this is not so bad. Another area where we're definitely cheating is the scrolling, because supporting huge documents is important in a code editor. We don't want to render everything to the DOM. What we do is when you're looking at a scrollable editor, actually only the part that's currently visible is rendered to the DOM. The rest is not there. Can be illustrated with a little animation. Here we're scrolling across this huge document. Everything is missing except for the part that we could currently see and a small margin around that. And the rest of the scroll bar is produced by a big statically sized div, which is set to the height of the actual content, with the result that the scroll bar is correct, and whenever a scroll event fires because the user scrolls, we quickly repaint whatever he's looking at now with a small margin so that we don't have to repaint on every tiny scroll event. And it works almost perfectly, except that if you scroll very fast, scroll events happen after the actual scrolling was done. So you'll see briefly an empty space, and then the code flips in again. And this was very disturbing, especially on slower machines. So we fake the scroll bar. The scroll bar that you see in the editor is just a div overlaid on the actual scroll bar, with also a node put into it, which has the actual height of the document. So it'll be exactly the same scroll bar as the one that the actual scrollable div has. But if you scroll it, you're not actually causing this scrollable div to move. So this gives us time when the scroll event fires to first redraw and then update the scroll top position of our scrollable div. As you see, once you start lying to the user, you often need more lies and more lies to cover them up. Recently, Mac OS 10 Mountain Lion came out, which has a very nice innovation, transparent scroll bars. So now the trick of overlaying the real scroll bar with a fake scroll bar is obviously, it's showing. You see both of these scroll bars and are slightly out of sync, and it looks horrible. So enter another hack. The actual scrollable div, which has this scroll bar that we want to hide, is made a bit bigger than the actual editor. The editor's wrapper is given overflow hidden, so you don't actually see the stuff that sticks out. That makes the scroll bar, the one that you see in gray here, completely invisible, and everything works happily and fine until the next bug is found, and I have to come up with an even more complicated model. As I mentioned, big files are important. Miguel actually mentioned in his talk that the Chrome's internal editor has problems with big files. It just gets slow and unresponsive. There's actually an experiment underway to integrate CodeMirror in Chrome instead of this built-in editor for this very reason, that it scales better. One obvious problem is, of course, representation of your document. You can't really cheat there. You need to put the whole document in memory if you want, at least I don't want to deal with any other model where you're getting your document from the server as the user scrolls. You could do it, but that's not what CodeMirror does. But fortunately, modern JavaScript engines are very efficient in the amount of overhead they put on objects and strings. And even if you have a 1,000,000-line document, it will be a few megabytes of string data and add a few megabytes of wrapper data to actually put these strings in a data structure that we can access. It's still not that bad. Everyone has 4 gigabytes of RAM, and if they don't, they shouldn't be editing such huge files, is my current position. An interesting question is, how do we represent then this document with all these strings in it? The first version of CodeMirror just used a flat array. That worked relatively well because in the first version of CodeMirror, the environment was enforced that all lines had exactly the same height. So one thing that this data structure must support is if you click on the document or you do something else where you want to find out which character is under a given XY coordinate on the screen, you have to somehow convert from vertical offset to line position. If all lines are the same, you just divide by the line height and you're there, and it's easy. But then I added features like line wrapping and code folding, which makes some lines vanish, and I added a feature where you can add inline widgets, which was what this linting feature used before, where you just put another DOM node in the middle of your editor, which also screws up the height of lines. So something more advanced was needed. The operations that this data structure should support is converting between 3 representations of lines. Well, 3 ways to address them. First, by line handle, which is basically if you have a line handle that refers to a specific line and someone presses enter before that, the line number will increase, but you still have the same text. And often you need that. The API exposes that where, for example, if you add a widget to some line, you later want to be able to remove it. So you need to track this line somehow. These must be convertible to line numbers and line vertical offsets very quickly. And the same the other way around, go from a line number or a vertical offset to an actual line handle. Internally also the editor does this all the time, so this has to be fast. Another consideration is updates have to be fast. If someone pastes 1,000 lines, there should not be a noticeable pause because all these lines are inserted in some expensive data structure. Similarly, if someone is typing very quickly, these tiny micro updates should be very, very fast. Because an irresponsible code editor which doesn't immediately respond when you do something is just one recipe for a headache when you're trying to do something. So the format that I came up with was a tree, obviously. You want to index by some properties, so a tree really is an obvious candidate. What I ended up with was not some kind of regular binary tree, but a Btree, which is a data format used by databases mostly and other on-disk file formats, which is quite a far cry from a code editor, but it fit extremely well. What a Btree does, for those who are not familiar with the data structure, is that it's a tree structure. Each node has a very high branching factor, so lots of children under one parent node. And all the data is stored in the leaves, which are themselves bigger than a single value. They store a whole range of values, and they can grow and shrink. Like there's a minimum and maximum size for these child nodes, so that if you just remove one line, you can just remove it from the child where it's in and be done. You don't have to rebalance anything. Unless the child is empty, then you kill the child. Similarly, if you insert, the balancing algorithm for a Btree is simple and cheap. What CodeMirror does is insert everything in the child node that happens to refer to the current position where it's inserting. And then if that overflows this child node, it starts splitting it into reasonably sized leaf nodes. If there's too many of them in the parent node, that's split in turn and it propagates upwards in a very cheap way, which is friendly to bulk updates. If you have a classic red-black tree or something and you want to insert 1,000 nodes, even if they're all adjacent, you have to insert them one by one because the algorithm is defined in single insertions and single deletions. Btrees are much more flexible and very simple to implement. So this was a great fit. I guess it's best demonstrated with a visual demo. Here you see a CodeMirror instance on the left, and a visual representation of the document tree on the right. So here, this is a document with 155 lines, height of 5,500 pixels about. The tree has only a depth of 1, so the root node contains a bunch of leaves. Under each leaf, I display the lines that this leaf contains as little colored blocks, where the color is the hash of the content of the line and the width is the height of the line. So I turned on line wrapping in this demo, so you can see that some lines are wider than others. And if I fold something, you'll see that some lines become very low. And the height changes. They propagate to the parent. So the root node always has an up-to-date view of A, the amount of lines in the document, and B, the total height of those, and allows for quick indexing. Say we want to find line 60. We start at the root. We see that the first leaf has only a size of 30, so that's not the one we take. We track that there's 30 remaining, so the second leaf has 25. Still not the one, there's only 5 remaining. We go to the third leaf, and that's a match, so we just take the 5th line of the third leaf. And because these trees are extremely shallow, because of the high branching factor, these kind of lookups are blazingly fast. The same is for height, because height and line number both increase in the same order and both monotonically. We can use 2 quantities to index a single tree, basically, which is great and cheap and very pleasant to work with. I'll try to demonstrate the splitting algorithm, the balancing. So here you see little orange nodes appearing because I'm adding empty lines. Then when the top leaf hits 50, bang, it's split in 2, and half of it just becomes 2 leaves, which is a trivial operation for the editor to perform. If I start to just paste lots of, like here you have a very simple tree. If I start to just paste lots of junk, here we have 25,000 line documents. You can see that it's still pretty responsive. And the tree is now 4 nodes, 5 layers deep. So it's still very fast to look something up. You have to jump through a few more nodes to get somewhere, but not a lot. And since you're usually editing in a relatively small range of the document, the cache will also be used pretty well because these are arrays and nodes, and it's only touching a bunch of them all the time. I mean the memory processor cache. And deletion is, as I said, it's actually insertion is clever enough to always produce a balanced tree here, but deletion is a bit more simple. It'll just, when you... Oh yeah, I need more than 1 leaf, sorry about that. When a leaf becomes empty, it just vanishes. If a branch node falls under a certain size threshold, it just merges itself into a single leaf. So this whole implementation is maybe 150 lines of code. And because code size is also an important consideration in a JavaScript library where the client will always be compiling it and downloading it, and you don't want to use techniques that require megabytes of code because then it's just not usable anymore. Modes are what are the word that CodeMirror uses for language specializations. These are the distribution comes with about 50 modes at the moment, which are small JavaScript programs that act like a tokenizer or optionally even a full parser, depending on how clever you want your mode to be for a given language. These are the major ones. They range from 25 lines for the div mode to 800 lines for the Perl mode, which I didn't write and which I never even dared to look at. And the way they work is that the editor uses them to run over the document, 1 token at a time, 1 syntactic element at a time. They basically move a stream forward past the syntactic element that they parse and then return a style for this. So a style could be string for a quoted string or comment for something that looks like a comment. To do this, this is their basic interface. Often you need some kind of memory of what came before if you want to assign a style to something. For example, in a multi-line comment, you don't know from your current text that you're in a multi-line comment, but you saw, for example, /* in JavaScript earlier. So modes keep a state. Some modes don't use a state because the language is trivial enough to parse without any contextual knowledge. Most nodes do. They define a method start state, which is something that returns a state object for the start of the document. And every token, every time a token is parsed, they get access to the state, and they may update it, for example, setting a flag. We are now in a comment. And then there's a bunch of optional extra methods that these modes can expose to do more clever things. For example, indentation, which given a context, a state, and a string, which is the line after the current point is being indented, returns an integer saying the amount of space to which this should be indented, so that the context that's already being tracked by the state can be put to good use when you're pressing enter and wanting auto-indent, or selecting a block of text and re-indenting it. One problem there is if line 2501 changes, you don't want to reparse the whole document, because that would be a humongous waste of everyone's CPU cycles. So what CodeMirror does, it occasionally copies the state. They're defined in a way that they are copyable, and if the mode needs them to be copyable in a specific way, it can also define a method for that, and stores these state instances along the document. And then when, for example, well, actually, when you start, it only parses the currently visible viewport. Then as you scroll down, it'll parse more and more of the document and store these state instances everywhere. Then if you sit here, for example, and make a change on the little red line, it only parses from the change, reparses from the change down to the end of the current viewport. So this is also a very bounded amount of work that needs to be done. If we assume that the viewport is no more than a few hundred lines, most modes can parse about 50,000 lines per second. Some of the more advanced ones, which keep a lot of states, they're more like 20,000 lines. But still, a few milliseconds should be all it takes to reparse a screen full of code and make sure everything is consistent again, at least everything that you can see. There's of course also the situation where you scroll down here and somehow manage to change the third line of the document. Then it has to parse more. In the common case, parsing and re-highlighting happens synchronously. If it can see that there's only a given maximum number of lines between the start of its range and the end, it just does it and you don't even notice it because it's very, very fast. There are also situations like this, or when you scroll down your document really fast, where there's just too much work to be done. What it does then is it makes up a state somewhere in some line. It has a heuristic where it takes a nearby line that is the least indented, which in most languages gives you at least some context, because the least indented lines usually start the blocks. And uses that made-up state to re-highlight synchronously, and then kicks off a pseudo background thread using setTimeout to actually do the full highlighting work, which is like, it works for a given time slice, which is configurable. If it runs over that, it stops and sets a timeout for itself to continue again. And in that way, it doesn't actually hamper responsiveness. As soon as you're typing, it stops background highlighting again, so that you don't get a noticeable slowdown from this work. Actually, that may be overkill because it's so fast to highlight, but in older browsers, in older versions of CodeMirror, it was slow enough to justify such an approach. And it's probably still, if you have this 25,000 line document, it still helps. So what can you do if you have an arbitrarily clever real program as a highlighter that actually is run over your document? You can do actually some analysis more clever than just highlighting. Here we have an XML document. The parser keeps the current tag context in its state, and when it encounters a closing tag that doesn't match the thing that happened to open the current context, it can tell you that you probably made a mistake because you have a mismatching tag. And similarly, if I that was not what I intended to do. If I make a mistake here at the top, the highlighting will cascade down because it re-highlights stuff on change, and it'll tell me that, yes, I have a mismatch tag again. Cooler is the JavaScript mode, which knows the difference between local and global variables, and gives them a different color. The definition of a variable is made dark blue here, and use of a local is made light blue. And you can see, for example, that console, we can even make them bold to make them jump out even more. The console is a global, whereas the others are locals, which is especially useful if you make some typo somewhere. It'll kind of jump out at you that you're not using a variable that's currently in scope. And since in most code the globals are way outnumbered by the locals, this creates a nice visual pattern to warn yourself when you're doing something global. The auto-completion actually hooks into this knowledge about locals. So if I say array here, it knows that, yes, I may want to complete to this local, whereas if I do the same here, I get no completions because the local doesn't exist. So it's a very, very primitive form of context-aware completion. This approach to writing modes, where they're basically a function that you feed a stream, makes them extremely composable, which allows things like this mixed mode HTML, which is a kind of wrapper multiplexing mode between several other modes. It starts using the XML parser, well, the HTML configuration of the XML parser, and when it encounters a style tag, it switches to the CSS parser. So this one here knows how that should be indented, even though it looks like it's inside an HTML document. It has the context-sensitive, it gets the context of the CSS file. And similar, if you find scripts, it'll switch to the JavaScript mode, and at the end of a script tag, it'll switch out again, and that allows these modes to compose, which is also used for a lot of templating languages and PHP and other such things. Just last week I brought out the first beta of version 3 of CodeMirror, which adds some new features like bidirectional text support, like Arabic or Hebrew text, which is a huge headache to get right in an editor because you can mix Hebrew and Latin text in a single line, and the Hebrew text will kind of flip around because it's written right to left. So if the cursor is moving through this, it has to know a whole bunch about obscure Unicode properties of characters to properly move in the correct position, move the correct way if you press left. And similarly, selection drawing becomes quite a bit more complicated because it's no longer a single continuous block. It may jump all around because the code is basically no longer continuous from left to right. One thing that is on the radar, but currently pretty sad, both in CodeMirror and ACE, is mobile support. So mobile violates a whole bunch of assumptions that we rely on to do this hack. The biggest problem is that you get these nice selection helper caret thingies if you select something. Since it's not a real selection that we're creating, we don't get those, so a lot of features are locked. Basically, you can't get at them because you don't have this selection interface. I haven't looked deeply into how hard it would be to fake this. Something will have to be done because mobile is getting huge, and we should support it at least relatively decently. Currently, the editor works. You can edit. You can on most mobile browsers even scroll, but that's about the extent of it. It doesn't feel native, and it's not a pleasant experience to use. Since this is all open source, it's slow going. I don't have, I'm not independently wealthy. I don't have the time to spend months on this just out of my own time. I had a successful crowdfunding round 2 months ago where I spent 1 month working on a bunch of new features like bidirectional text, and so that made it into version 3. Who knows, I'll probably try something similar again. This is actually working relatively well for me, the profitable open source model. I spent the first 5 years working on this project just completely out of hobbyism, but recently some big companies are buying support for this, and it's becoming sustainable for me to maintain this. But yeah, mobile brings me to the other editor I mentioned before, Orion. They use a completely different approach to do this. They use the browser's content editable functionality, which allows you to basically create a kind of rich text HTML editor inside the browser. You can say this element is editable, and it'll just become editable. You can click on it and get a cursor, type something, and then the browser will do whatever it feels is proper to let you edit this code, which has the advantage that you're talking about a real editable component. So mobile, for example, becomes a lot less intimidating. They claim to work on mobile. I haven't actually tried it, but I can imagine that they've gotten that to work because they get a lot of the features automatically. CodeMirror 1, actually, the first version of CodeMirror before the big rewrite that I did in 2011, worked like this. It used content editable. So I have some experience with it, and it has its own set of problems. As I said, the browser can do whatever it wants when you edit this code. There's no specification of how content editable or design mode, which is a similar feature that some older browsers have instead of it, how it's supposed to work, what it's supposed to do if you press enter, for example. Some browsers insert BR break note, some of them add paragraph notes. It's a surprise, and then the editor has to go back in there and somehow renormalize what you're looking at to something that's displaying its own view of your document. Another problem is that selection APIs in arbitrary DOM structures are varying between browsers, buggy, and CodeMirror 1 had about 700 lines of selection handling code. I'm not anxious to go back to this situation. But yeah, as I said, it does have advantages. One of the main problems with CodeMirror 1 was that it was slow on huge documents because it put everything in a DOM, the editable DOM no less, which is even slower than normal DOM. Orion gets around this by using a similar trick where it's only putting the visible part of the document in the actual DOM. So I'm very curious how they'll develop further and what's going to happen there. That was my talk. That's where the project lives, my project. Yeah, and that's me on Twitter. I would be very happy to take questions or remarks or whatever else you might have to add. A VI mode was the question. Is there a VI mode? This is one of the areas where I've been getting lots of contributions because lots of people apparently want a VI mode, and there is something that emulates a lot of VI functionality, but I can't tell you how good it is to an actual VI user. So I've been, one of the motivations in the rewrite from CodeMirror 1 to version 2 was CodeMirror 1 was drowning in hacks, and they're all interacting, and it was getting horrible. So 2 takes a conscious effort to keep them to a minimum and isolate them as good as it can. So it uses feature detection and wrapping lots of things in functions as long as that's possible. And it's constantly looking for ways, like sometimes the obvious way is buggy in some browser, the obvious way to do something. And I've learned to look for another way that's straightforward and that actually works cross-browser to get around writing if Opera then this, if IE then this. But there is unfortunately still such code. It's relatively minor in version 2, which is how I keep this project sane. because as I said, these hacks tend to interact in unexpected ways, but it's there and I just deal with it. I keep a lot in my head, unfortunately. That's part of the development process. It's been growing. Like I have only recently learned to I like testing. I have used testing a lot for a long time, but only in things that were test friendly. A UI component is about the most test unfriendly thing you can think of, especially if a lot of the problematic behavior is related to browser bugs that you only see when you run it in that specific browser. We currently have a relatively big test suite, which is run in Phantom.js, which is a fake WebKit under Node, on every commit. And I have, this test suite is runnable if you just go to a web page, and I run it before every release in every supported browser. But it's not perfect. Some things I just haven't found a way to test them mechanically, like without inputting my own events. There's this framework for this called, I forgot. There is a framework that lets you spawn a browser process and then communicate to an HTTP socket to fire events on that browser process. Exactly, Selenium. That kind of worked, but I still couldn't fire all the events that I really wanted to fire. Like input method editing text is one very flaky, very fragile area. That's not supported by Selenium, and it's quite a pain to set up. So it's not actually, there is a stub that does a few tests through Selenium, but I'm not developing that because it's just very painful. Then thank you for listening. Have a good day.